All right, let's talk about something. What do you guys want to talk about? Let me get myself all figured out here. Who am I? Which one am I? Where am I going? Going this way? No, I'm gonna go this way. Yeah. Tired. Sorry, been a long day. What am I doing? What am I supposed to do? I'm gonna drink some of this first. Okay, I think I'm more better now. Get a little caffeine in yet. Oh my God, good to go. So, hey everybody. So it's been a long day for me. Long week, a lot of work. Anyway, as I really want to get this out. I really want to get Lab 6 out for you guys because I think you can have a really good learning experience from understanding how Automation Studio works, things that we can do. I'm not only going to show you how to run this, but I'm going to show you little things that you can do with the components to make them more functional, to make your circuit look better, to make your circuit look so that people like looking at it, like interacting with it. And the placement of things and how we can put labels for items on here and then run the circuit itself. So let's jump into this and take a look at this circuit. By the way, this thing's in the way, so get rid of this. So here we go. Here's the circuit, and I guess I can zoom in a little bit. Right. So we got the load. What I did was I've put some labels on here, right? So I've put words on here. By the way, when you write these words, when you put in a text box, I'm just going to put a text box in here. I'm going to put a text box in here, and I'm just going to type something. There you go. That's what we're going to do. Whee! Type something. Okay. Okay, and then whatever, something more. So now, let me just go back here. Now, if I take, that's done, right? I'm just going to hit escape to get rid of this. Now, if I take this and put this somewhere here, and I want to move it, if I want to move something else or grab something else, if I want to grab this wire here, this hose, pardon me, I can't grab this hose because this is in the way. Dude, always, I mean, I told you this like in a video like way long ago. So what you do is you want to grab onto this, and you want to, oh, there you go, add patience with Automation Studio. I mean, have patience with all of your work. There you go. I'm going to make this as small as I can. And that way, it's going to go in the, so I can click on these wires. I can click on these hoses. I can operate this thing. It's not going to try and select this. Anyway, that's just something heads up there. So I made this. When I took this, actually, you know what? Undo is great. I'm just going to undo until everything goes back to normal again. There you go. So, undo. I put that there because I changed this cylinder I modified the cylinder to put 80-pound load on it. And you can do that. It's actually really important. And you know, if you don't do that, if you don't go in there and change the setting on that cylinder to put an 80-pound load, it won't really simulate very well. It'll go up and down like 5 or 6 times. But with an 80-pound load, you'll notice actually it only goes up and down once. Let's go in there. I'm going to click on these components. So over here I put 80 pounds. We could put that, let's put that up to like 200 and see what happens. Whoa, that's a 200. Okay, good. So I'm just going to click on that and go there. Now the load on this is 200. I'm not going to, this is just a text, right? I put that there for the whatever user is going to be reading this. So, you know what? I'm going to run this. And we'll study what happens here. I'm going to show you how to do placement of these components and what to do if you want to write information about these things to be displayed. So let's go here and let's just run this. I'm going to zoom out a little bit too, I think. Okay, good. So I've zoomed out. So what's happening here is that's closed off. If I do this, I've got my ball valves set so that you can have normally open and normally closed ball valves. So mine are normally closed. So in this case, if they're white on either side, it means they're closed. If they're black, it means, I guess, air's going through, whatever, they're open. So that's closed. So as soon as I start my system, that's closed. All of these are closed. Actually, I'm gonna close that one. I don't want my backup charging right now. So here we go. Now I'm waiting till the pressure gets up. Now, while we're here, let's talk about what happens with this. My pressure here is set to 80 psi. This tank is going to go up to 80-ish, and it'll just stay there. But why is this pressure going up? And what happens if this pressure goes to like 3 or 4 or 5? Like, it's just going to keep going and keep going and keep going. Is that okay? Well, in this particular lab, it's fine. Don't worry about it. You're good. It's just going to go up to ridiculously high numbers. But what's going on is that in an actual control system for pneumatics, what would happen was we would have another control. We'd have the prime mover on here, which is a motor connected to the pump. That motor is going to be connected to a pressure switch. And the pressure switch will have a setting on it. It's actually adjustable with a screwdriver. So when the pressure gets to 80 psi or above 80, like 110, maybe 100 psi, because the regulator is set to 80. So I'm going to have my tank stop at about 100 psi. Typically, you want to stop your tank at 100. You don't really need more than 100 psi in your tank, unless you have an operation that runs on higher pressure, which is essentially not really necessary because you should be designing your systems for under 100 psi. Anyway, 100. If you want to go more than 100, 150, 120, 200 psi, you need a specialized tank. You have to go and get a special tank. Plus, you may have to think about a different kind of compressor as well. What I'm saying is, as long as your pressure is set to, your operating pressure for your system is 80 psi, then you can set your tank to 100. Again, this is going up and up and up. What's going to happen is that you have a pressure switch on your electric motor, or whatever the prime mover is. Could be a gas motor, a diesel motor, that's running the compressor. And there's going to be some kind of switch that says, hey, the pressure has reached this amount, the switch will open. Again, that's adjustable with a screwdriver. When the switch opens, it's going to turn your prime mover off, in this case an electric motor. And the electric motor could be DC, could be AC, could be three-phase AC, really big, strong motor. Could be just a 12-volt motor, could be 24-volt DC motor, whatever. And again, it's just a switch that opens and closes. So it's not, you're not going to get these ridiculously high numbers. Actually, that stopped at 435. That's probably a setting on this compressor. So let's just move on. I'm going to run this a few times. Okay, it's going to go up, it's going to go down, it's going to go up, it's going to go down. Now what I want to do is I want to simulate a breakdown. But to do that, I want to fill my tank. So this tank is going to fill up to 70 psi, and that's because the regulator before it is only regulating that much pressure. So this thing has 70 psi in it. You know what? I'm just going to shut this off. Now, if my system dies, right? Let's just say for some reason my compressor died, my tank was empty, and there was this, maybe the regulator, there was a failure in the system, and there's no air to lift this heavy latch on this cargo ship. Well, we need somebody to lift it up. It needs to be lifted up. Maybe it takes like 2 people to lift it up. But you want to do it automatically. So what you do is you go over here and you hit this. Oh, by the way, sorry, let's simulate a failure. So I'm simulating a failure here, and this failure is the system is open somehow, or it turns off, or whatever. The regulator dies, like I said before. So the pressure goes really low. Now the pressure here is low, and what I'm going to do is I'm going to run this once, and you'll see it doesn't even move. And the pressure's gone down to 0 because I tried to use it, right? So it's not working. I'm going to turn my backup on. Now my backup is here. And that means I'm using a shuttle valve in here, which can be used as an OR, as a function. But in this case, it's a shuttle valve. And this air is coming in here and it's running the system. Now I have the availability. Now the pressure was at 70, but now it went down to 46. What? Why did you do that? Well, because look, this is an airline. It has volume in it. Before, actually, this is an airline. It had volume in it before it was empty. This line actually had really low pressure in it. This line was connected to this cylinder, which goes all the way down here, which is this big empty vessel. So our pressure just went down quite a bit. You may actually think about putting a 3-2 valve in here. A 5-2 valve in here. If you put a 5-2 valve in here, the extra air coming from here wouldn't vent into this part of the cylinder. This is just design thinking. Because what immediately, as an automation student, is awesome. You build this stuff and you run it and you're like, oh, pressure went down considerably. And that pressure is actually being applied to retracting it. But I want to open it. I don't want to have that. I don't want to use that pressure to close it. It's already closed. I'm going to use that pressure to open it. So you might think, I just wasted like 30, 25 PSI retracting it when it's already retracted because I'm just filling this big empty gap that's a cylinder. So what I might do is, again, I would put a 5-3 in here. Now remember, the 5-3 with a blocked center wouldn't allow air to go that way. And your pressure would remain at a higher value. Anyway, let's move on. So this is going on. I'm going to run it. I'm going to make it go up. Remember, I put this up to 200. So let's see what happens. It goes up once. Nice, nice. Now the pressure's gone down. Let's see what happens if I take it down. It goes down. Now the pressure is only 12 psi. I don't think it's going to lift it. Actually, if you did even the math on whatever the size of the cylinder is, it wouldn't have enough to lift it. And I'm going to lift it. It's not even moving because I got 200 pounds of load on there. Let's just do a little interesting thing here. I'm going to make this down to 10 pounds. Really low. And I bet you it'll run many times. Okay, good. So I'm going to simulate it. And I'm going to turn this off. I'm going to leave this venting. And I'm just going to turn this. Sorry, I'm just going to turn this on. Wait till it gets to 70. Oh, sorry, I don't want that to vent. I'm going to let this get to 70. And then I'm going to shut this other system off. Okay, so we're getting there. Okay, 30, 40, coming up. So, and then I'm going to simulate a leakage. Actually, I'm going to turn this off so the leakage doesn't go back. Okay, so we'll just get up to 70. There's 70. I'm going to turn this back up off. Air's not going through here. I'm going to vent this out, so that's going slow. I'm just going to run this to vent the system really quickly. Okay, good. So, it's done. Okay, good. So I'm going to open that up. Now, I'm going to allow the backup air to come in here. Again, it's gone down to lower pressure. And I'm going to actuate it. It's going to go up. It's going to come down. And I think it'll go up again. It went up. It's going up because this was only set to 10 psi load. And I bet you, actually, do you know what? I'm going to charge this guy up again. And I'm going to, can I set that? I can't do a setting. Let me just do this. Bear with me just for a sec, because this is interesting. What if it has zero load? What if it has zero load? Let's see what happens. Okay, good. So I think you guys might be setting it to zero load because I don't think I gave you instructions in the lab to set it to something. Anyway, if I did, whatever. Let's just see what happens at zero load. So that's coming up. As soon as that goes to 70 psi, I'm going to shut this off. And then, there we go. So shut that off. Now I'll do a vent, and I'll just purge the system. So from any pressurized air that's in the tank, and you can see it's gone down to a very low value. Okay, good. So now let's do the backup. I'm going to shut this. No, I want to. I just did a silly. Okay, let's fill this up again. Okay. Good. 40, 50. Hope everybody's good. It's Monday. I'm a little slow. I partied this weekend. I had popcorn and ice cream last night. That's my partying. Okay, I'll shut this off, and I'll turn that off. Okay, good. So now let's run this. 0 psi. Actually, I'll just run this to get rid of the air pressure that's in the tank. Okay, good. So now I'm going to turn this on. It's not even going back. As soon as I do this, it will go down. Okay, good. So now I've got this pressure. That's off. Let me run it. It's going up. It's going down. It's going up. No, it's not going all the way. Interesting. Okay. It's going down. So even with zero load, it only went one time or 1.5 times. But with a load of 80, typically, I had that set to 80, and that's what. Then it went one full time out and back, and it wouldn't even go out again. We saw that at the very beginning. So, just kind of let's talk about some other stuff. Just some where you're putting your components. Now I put this down here. Typically, actually, I said built it this way so I could put this into a drawing. So it's kind of 8.5 by 11, a landscape, right? Or no, portrait. If I wanted to build a landscape, I'd probably put all this stuff down over here. But so I put these components together, and I put space in between, and this is just words that I set here, and these are just words. I put them in. And my shuttle valve, yeah, I put this. Let me show you one thing. This you can move around. And actually I had this. Typically it'll go here. And then that kind of got in the way a little bit. I mean, I think because I shrunk some stuff in. I think I moved some stuff around. But wherever it is, I kind of put that up there. And I thought, just leave space. It separates this from here. Again, this can be actually put down here, which is maybe actually up here, which is better. And that allows me to take a screenshot here and do this. and then really sneak it in a little bit more, because remember that PSI was over here, so that allows me to do things. So you can move labels around. So let's take a look at the label and how you do it automatically. Now let's talk about these arrows. If I unclick this arrow, it doesn't tell me any information about it. So actually, these are certain things. You know what? I can even put pound 0 pounds extension load. Let's put this back to 80. Actually, I may have wasted my time and labeled that, because I could just click this. And now it tells me my load, right? But it didn't actually say load. So I can put this over here. And I just said here. Wow. Long day. So 80 pounds. So, but that's okay. I mean, you could do that. I think that's probably better, because it says the word load on it, because you might not know what the 80 pounds is. I mean, you would actually, because it's a force, so you know it's a load. Anyway, what I'm saying is you can put these things on here. Let's go down here to the regulator. Now the pressure is set to 80. And if I do this, it actually says 80 PSI on it. And you know what? Again, I probably wasted my time there. I can take this and just, whoops, I can put that there. And it's just, obviously, it's a pressure regulator, and if there's a pressure set above it, we know it's 80. And the other thing is that I can just use my arrow keys to, whoa, I don't know what this is. Oh no, that was going to crash. I can use my arrow keys to move this around as well. So any component that you click on, any of these arrows here will show whatever that thing is that you've clicked on there. Let's take a look at this tank. So that's 120 PSI. And the volume, it's actually nice to show the volume as well. There you go. So that's kind of in the way. So what I'm going to do is I'm going to put that inside there. And I'm going to put this maybe here. If I put that there, it's kind of a little bit busy down here. You really have to think of your reader. You have to think about who's actually going to be looking at your stuff. And make it as easy for them to read it. Again, there's 120 PSI here. You know what? I'm just going to select, see if I can select all of this. No, I can't. It's difficult. Actually, you know what? I'm going to select just this. And I'm going to move my arrow key down here. That's kind of maybe a little bit better. And again, you know what? I can do this. I can get rid of this. And I can click on this. And that is set to 70. So I can just click on this. See, these arrows are great. Again, this should probably be moved over in there. Nice. It's consistent. These two are the same. Oh, do you know, I just thought of something. See how that regulator and that regulator right there? If you want to make people happy when they're looking at your work, do this. Isn't that nice? I mean, they're right on top of your visual. Some people will notice that. Some people will feel just better about seeing those things in alignment like that. It's true. Good. So you know how to run it. We talked about how to run this, how to put the gauges. I'm going to put this back. I'm just going to double click on this component and put this at maximum pressure. Oh, it'll just show the pressure. I'm not sure. Oh, do you know what? I just did a silly. Because I said maximum pressure. I'm just going to say pressure, whatever the pressure is. And again, that was over there. Interesting. That pressure is there. And I wonder if you can write like, it's a maximum pressure. It's on, off. By the way, I'm going to click on this. If you click on this, it brings up a lot more information. A lot more information. Does it say normally open or something? Or normally passing or anything like that? It doesn't. Okay, so it doesn't say it. But if it did, if I wanted to show that it was normally passing or normally non-passing, it doesn't actually have a normal state because it doesn't have a spring in it. So I guess it doesn't say that. But I mean, it's just that when you run in Automation Studio, when you run it, it does have a normal state because it's naturally like this or like this. Actually, maybe it's just like the last way I left it. No, I'm not sure. Oh, do you know what? I think these are different valves because that line is straight and this line isn't. That's interesting. That's maybe something for you to check out to see what's going on there. Because when I run this, that is allowing air to go through. This is not allowing air to go through. That's not colored. That is colored. And we know that when it is colored, air does go through. That's a consistency. But in this case, this line is straight and this line is straight, but they're different colors. So maybe I actually did use different valves. It's a shut-off valve here. And there's a valve there. It says shut off, normally open, and this is shut off, normally closed. Interesting. So I did use a normally closed here and a normally open. So they do have states on them, but that's just Automation Studio because the concept of normally passing or normally not passing or normally open or normally closed means that there's a spring. And I think you've had enough of me talking and you've learned a lot here. Hopefully you have. So that's all I really wanted to unpack with this. You guys have already put these in and you know how to do these. You know how to get these components and you know how to get this. Do you know what? Let me just, you can change the size of this. So for an accumulator, that's a half a liter. I mean a half a foot. And my accumulator, again, this was probably the volume here. This is cubic inches. Do you know what? Let me go for cubic feet. Yeah. So this is much smaller, right? If you want more data, you can click on this. And that's this, and that's good. So you could actually write it. You could just write it in cubic inches here, and then, sorry, I'm just gonna, yeah, it's good to label this. I'm gonna put that there. I wonder if it says cubic inches. I guess it will. Oh, I don't know what just happened. Oh, it doesn't say. Oh, there it is there. So I don't like it that it's like that. I might even just do, again, you know what? It's all about making your drawings look good. I'm going to do this. I'm going to do this. And then I'm going to disconnect this wire, I keep calling them wires. I'm just going to move this out of the way. I'm going to hit Control H and then Control H and Control H again. There you go. So now I'm going to hit Control H and H again. Now I'm going to do this. And then I'm going to come down here. Oops, I didn't mean to do that. I want to do that all on one thing. Okay, good. So now I'm going to take this. It's kind of, you know what? No, I'm going to rotate it like this. Control H is nice because it's nice and quick. I'm going to put that there. Oh, no, I'm not going to. I didn't mean to do that. I meant this. Okay, good. So now that can go. Whoa, no. Control. I love Control Z. I love it. I keep my fingers over it. Okay, so now did we? Yeah, okay, it's somewhere. Oh, there it is. There. No. Okay, here we go. Nice. Look at that. Okay, that's nice. That's kind of. That actually looks better than the way I had it before. It feels better. I don't like this little jog. Do you know what? I don't like the jog. I'm gonna go down and then down. Actually, that's, you know what? It just looks better. Looks better. Looking better is important. Again, it's all about your reader. It's all about who is going to be looking and critiquing and using your work and how they feel when they look, when they see it. Good. There you go. I think that's good. I think we went over a bunch of good stuff here. And you guys know how this system works. I mean, you've run it yourself. You figure it out. If you don't, run it more. Figure it out. I mean, I ran it one time. Play around with the load, maybe. Hey, do you know what? Play around with the size of this tank. Yeah, if you increase the size of this tank, it'll be good. Plus, do you know what? Put a DCV, put a 5.3 DCV in here and run it and see what happens to the pressure. That's all. Okay, bye.